So hi everyone. So myself Kaushik. I am from civil department of tourism. So today my topic so today is today my topic is about the types of events in probability and statistics. The probability and statistics focus- focusing on the types of events that shape our understanding of randomness and data analysis. There are some certain events in probability and statistics, events are outcomes, a set of outcomes of an experiment. The types of events can be classified in various ways, based on their relationship, occurrence, and properties, like simple event, compound event, complementary events, exclusive events, non-mutually exclusive events, independent events, dependent events, exhaustive events, collectively exhaustive events, conditional events, joint events, union of events, intersection of events like conjunctions. There, here are some here are some events. Impossible events are like an impossible event in improbability theories, an event that cannot occur under any circumstances. In other words, the set of outcomes for the event is empty and its probability is zero. Like no outcomes are there are no possible outcomes in the sample space that would satisfy the conditions of the event. The probability is P of A is equals to zero, and the notation is denoted as null set or pi. example example like rolling a 7 on a standard six sided die is an impossible event because the die only has numbers 1 to 6. Mutually exclusive events are the events that cannot occur at the same time. If one event happens, the other cannot, and the vice versa. In other words, the occurrence of one event excludes the possibility of the other event happening. Like exclusive events like no overlap, and the no overlap means the events have no common outcomes. The intersection is empty. In mathematically, it is P of A intersection B is equals to zero. For example, tossing a coin, the events getting heads and getting tails are mutually exclusive because both cannot occur simultaneously in a single coin toss. And for two mutual exclusive events A and B, the probability of either event occurring is just the sum of their individual probabilities, like P of A union B is equals to P of A plus P of B. Since the events cannot be happen at the same time in their intersection, whether their intersection is zero, like complementary events. The complementary events are like sorry, complementary events are two events that together cover all possible outcomes in a sample space. If one event occurs, the other cannot and vice versa. In other words, the event represents the failure of other events, like it is exhaustive The events together exhaust an entire sample space. One of them must occur. If if event A occurs, then event A, the complement of A cannot occur, and the vice versa. The probability the probability relationship in this event is like probabilities of complementary events is sum to one. Okay? And mathematically, P of A plus P of A dash is equals to 1, where P of A dash is probability of the complement of A, and it can the notation of the complement event A is denoted as A dash or A bar. A dash consists of all the outcomes that are not in A. The probability of event is known. The probability of its complement A dash can be found as P of A dash is equals to 1 minus P of A, and other P of A dash is equals to 1 minus 0.7, that's equals to 0.3. And one and second probability counting techniques. The counting techniques are the methods using probability and statistics to determine the number of possible outcomes or arrangements in a sample space. These techniques are essential for calculating probabilities, especially when dealing with the large or complex problems. The counting, the, co- the counting principle, like multiplication rule. This multiplication rule says that if one event can occur in m ways, uh, and a second event can occur in n ways, then the two events together can occur in mn ways. Mn ways. For example, like if you are choosing a shirt, there are some five options and a pair of pants, four options. The total number of outfit is find for the equals 20. And the factorial notation of this is the factorial of a positive integer n is the product of all positive integers less than or equal to n. The notation is equals to n into n minus 1 into n minus 2 into so on into 1. And there are some permutations like permutation is an arrangement of objects in a specific order. The number of permutations of R objects are chosen from a set of n distinct objects is given by the P of n comma that is equals to n n by of n minus r. Sorry. And these counting techniques are essential for solving problems related to probability and statistics, particularly when dealing with large sample spaces. Understanding this multiplication rule and permutations and combinations, the number of possible outcomes or arrangements, and at last, summarizing the key form. Okay. In conclusion, the content techniques are fundamental tools in probability and statistics, enabling us to calculate the number of possible outcomes in various scenarios. These techniques provide the foundation for understanding complex problems and computing probabilities. And there are some key concepts like multiplication rule, factorial, permutations, combinations, addition rule, inclusion, exclusion, binomial coefficients, multinomial coefficients. These techniques are crucial for solving a wide variety of problems, particularly when dealing with complex events in probability, and are indispensable for making informed decisions in fields ranging from statistics to computer science and operations. research. Thank you.